Hey everyone, and welcome to The Explainer. Today we're tackling a chapter that seems pretty simple on the surface, but man, it is so important for your Class 10 exams. Real numbers.
So, have you ever found yourself just staring at a word problem, completely stuck on whether to find the highest common factor or the least common multiple? Yeah, you are not alone. It's probably the biggest headache in this chapter, but trust me, by the time we're done here, it's all going to make perfect sense.
Look, we're not just going to throw a bunch of formulas at you like a textbook. No way. Think of this as us opening up a math master's toolkit. We're going to hand you the exact tools and even a few secrets you need to crush any real numbers problem that gets thrown your way.
When you really boil it down, this whole chapter is basically about two main things. First, you've got the whole world of HCF and LCM. Then there's understanding irrational numbers. So we're just going to tackle them one by one, starting with our very first and most important tool.
Okay, so tool number one. The absolute foundation for the entire first half of this chapter is just one simple process: prime factorization. Seriously, if you get this down, you've basically already won half the battle.
All right, let's see how this works with the numbers 24 and 18. First up, we break them down into their prime factors, right? So 24 becomes 2 cubed times 3, and 18 is 2 times 3 squared. Now, here's the cool part. From this one step, we can get both answers. For the HCF, you just grab the common factors and use their lowest power. And for the LCM, you take all the factors and use their highest power. See? It's really that straightforward.
Okay, let's make this even easier to remember. For HCF, just think common LELO. Just take what's common. It's all about what the numbers share. Then for LCM, think sub-LELO. Take everything. You've got to account for every single prime factor from both numbers, and you use its strongest, highest power. Those two little phrases, that's all you really need.
This is just a funny little reminder to always double-check your work, even when you're feeling super confident. Hey, that happens to the best of us. All right, let's keep going.
All right, tool number 2 in our toolkit. And this one is a fantastic shortcut. It's a secret formula that shows you this really cool relationship between the HCF and LCM of any two numbers.
So here it is. The HCF of two numbers multiplied by their LCM is always, and I mean always, equal to the product of the two numbers themselves. This isn't just some neat math trick, you guys. This is a super powerful tool for solving problems.
So here's the kam ki baat, the super useful tip. If you're in an exam and you see a question that mentions both HCF and LCM, ding, 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 a light bulb should go off in your head. This formula, it's almost guaranteed to be your key to solving it.
Okay, deep breaths. It's time to face the beast. Word problems. I know. This is where a lot of people get tripped up. But I promise you, there's a super simple trick to know instantly whether you need to find the HCF or the LCM.
So what is this magic trick, this game changer? How can you look at a big, confusing paragraph and know exactly what to do?
It all comes down to one simple question: the big, small rule. Just ask yourself, is the answer I'm looking for going to be bigger or smaller than the numbers in the problem? I mean, think about it. A multiple for LCM is always going to be a bigger number, and a factor for HCF is always going to be smaller. So if you have bells ringing at different times, the moment they ring together has to be in the future, right? A bigger number. So you find the LCM.
Let's put this to the test. You've got an army contingent with groups of 1,056 members. They all need to march in the same number of columns. Now, think logically. Could you have 2,000 columns? No way. You don't even have that many people. The number of columns has to be smaller than 56 and 1,000. And a smaller answer means you got it. You find the HCF.
Okay, and what about those super annoying remainder problems? Well, the secret is to just get rid of the remainder first. It's a simple 3-step process. Step 1, subtract the remainder from its original number. Step 2, now you've got new numbers that are perfectly divisible. And step 3, what do we find when we need the greatest number that divides other numbers perfectly? The HCF. You just find the HCF of your new numbers, and that's your answer.
All right, we're almost there. Let's wrap up with a couple of special cases. These are the kinds of questions that really test if you understand the nature of numbers themselves.
Here's a classic question you see all the time. Can the number 4 raised to any power, so 4 squared, 4 to the power of 10, 4 to the power of a million, can it ever end with the digit 0?
Well, the rule is actually super simple. For any number to end in 0, it has to be a multiple of 10. And what does that mean? It means its prime factors must have both a 2 and a 5 in there. So let's look at 4 to the power of n. That's just 2 squared to the power of n, which is just a bunch of 2's multiplied together. See? There's no 5 anywhere in sight. And if there's no 5, there's just no way it can ever end in 0. Impossible!
And that brings us to the final big idea in this chapter, irrational numbers. These are kind of like the rebels of the number world, right? You can't write them as a simple fraction, and their decimals just go on forever without ever repeating. So let's quickly hit what you absolutely need to know. Okay, listen up because this is important. You will almost certainly be asked to prove that a number like the square root of 2 or 3 is irrational. The fancy name for the method you use is proof by contradiction. The whole idea is you start by pretending the number is rational. You assume it. Then you just follow the math until, oops, you hit a dead end, a logical impossibility, a contradiction. And that contradiction proves that your first assumption had to be wrong all along.
So there you have it. We've filled up our toolkit for real numbers. We've got prime factorization for HCF and LCM, we've got our big-small trick for word problems, and we know about proof by contradiction for those irrational numbers. So now that you have the whole toolkit, which tool do you think is going to be the most powerful for you in your exams? Think about that and you'll be more than ready to master this chapter.